Welcome back, people, to our lesson practice review, where we are covering Chapter 1, Lesson 10, and the work that it includes. So we have our lesson summary to start. Lesson 10 actually kind of builds on an earlier lesson that we talked about scaling a function. This one specifically talking about scaling it horizontally by multiplying its inputs by a factor. The last lesson talked about vertically scaling it. Now we're talking about horizontally scaling it. So instead of multiplying by the outputs or multiplying on the outside, we're actually going to multiply on the inside of the function, or we're going to multiply the x values or the inputs. So if you can kind of see here, the first one that we see, f of x here, is our original red function here, and we multiply the inputs by 2. And what that does is that horizontally scales it by a factor of 1/2. So that's the kind of tricky part about horizontal. Similar to when we talk about shifting left and right, it's kind of the opposite of what we would imagine. So when we see this 2 being multiplied on the inside, that really is scaling it by a factor of 1/2. So in this case here, you can kind of see the 0.11 kind of now changes to the x value of 1/2, and then the y values stay the same. Same idea if we were going to horizontally scale it by a factor of 2. Well, the equation here would be we would multiply the inputs by 1/2. And so when we do that, what you end up seeing is that it kind of horizontally stretches our function. So let's see how this works in some practice problems here. For number 1, it says, what additional piece of information do you need to determine the horizontal factor k? And there's a couple different things that we might need, but really the main focus is we probably need some numbers because we don't see what's happening from the blue to the red here or vice versa. So there's lots of different answers to this. Like we would need to know what's the original function and which one are we scaling. We would need to know, what the coordinates of these points are and some of the x values. So there's a lot of different options on that would help us find that horizontal factor. For problems 2 to 5, write an equation for d of x in terms of c of x to capture all the points. So we're kind of playing the game here where we're trying to create the function that crosses these points. What you'll notice here is that it has the same vertex for number 2 here. And when we're doing this, what we really need to focus on are these points that we can kind of see that are getting smaller. We're like shrinking it horizontally because we start off with this x value here at 3, and then it becomes an x value of 1. Whereas this x value of 6 now becomes the x value of 2. And so what you can kind of see here is that each of these x values is being multiplied by 1/3. 3 times 1/3 becomes 1. 6 times 1/3 becomes 2. And then the same thing happens in the negative version of it. And so instead of, we're multiplying all these x values by 1/3, but that should tell us that in our actual c of x here, we're actually multiplying by 3 because it's the inverse of what we would imagine. For number 3, same idea. We got the same vertex here, but now we're taking this point at the x value of 2, and it makes it now become the x value of 4. So we're really kind of doubling these x values. This x value here of 4 now becomes an x value of 8. So if we are doubling each of these x values to get to our new version, remember our equation here, if it's doubling it, we're multiplying it by 2, we really are going to end up multiplying these x values by 1/2, the inputs. For number 4, a couple different things that are going to have to happen here. First of all, we see that kind of going the other direction. We see that this original function here kind of is increasing, but if we were to draw something that goes through these points, it is decreasing. So my first recommendation here is to make this number negative here because that is going to reflect it over the y-axis. And then from there, we need to figure out, is there any change in the x values? And in this case here, it doesn't look like there is because we're going from 1 and now we have -1. This has the x value of 2. This is -2. And so the numbers themselves are not changing other than the fact that they are becoming negative. So we're not stretching or compressing this horizontally. So we're going to leave that as just -1. So for number 5 here, we got a couple points. I'm going to start with this low point right here. A couple things about this. At first, it may look like, I want this to be stretched out and move this over here. But if we were to stretch this, then there would be no point that lands on this spot right here. And so, really, what I think I'm going to do here is I'm going to reflect it to make this point, land over on this side and also compress it because we can kind of see here if I were to reflect this point over the y axis, so making this negative, it would end up landing at -4, like right here. And then if I were to cut that in half or divide it by 2, then it would land on this point right here. And let's kind of see that happen with a couple other points. So let's take this maximum right here. This is at a +4. If we reflected it first, that would make it at -4. And then we divide it by 2, it would land on that spot right there. So same idea with, let's say, this point right here, which is at an x value of -8. First of all, we would switch it over to become +8 because the negative, divided in half, which would make it +4. And so we can kind of see that all of these points would be filling in if we not only reflect it over the y-axis, which is where this negative is coming from, but then divide it by 2, which, again, because we're on the inside of the function, we're really multiplying the input by -2. All right, problem 6 and 7. Has each graph been scaled horizontally or vertically? And so when we are going through this, we want to take a look to see, are the x values changing or are the y values changing? And when we see these, again, if we kind of take a couple of specific points to look at here, for example, this one kind of matches up with our new function. This one, it seems to me that they have the same x value, but then the y value is getting larger. Same thing with this minimum value. The x value stays the same, but the y value is stretching. And so we can kind of see here that since it's the y values that are changing here, we would say that this is being scaled vertically. For number 7, when we look at these, we can kind of see the maximums and minimums are staying the same. Let's say this point right here, but it seems to me that this point is now kind of being stretched out to become g of x. And same thing with, these points here being stretched as we go horizontally, not vertically. Because if we were stretching or compressing vertically, then it would be getting taller or shorter. In this case here, it seems to me that they are being stretched out horizontally in this one. For number 8, use at least 2 different function families to create a design that looks the same when scaled horizontally by either positive or negative factor. So with this one, what we really need to kind of focus on is, since we are scaling it horizontally, if we're scaling it by a positive number or a negative number, that means that when we reflect it, it needs to be the same. So for example, there's 2 that come into mind. The first would be an absolute value function. So if I were to create something that looked like this here, that would be, the same whether it was positive or negative, because if we flipped it negatively, for example, like this point right here would land exactly on this point and vice versa, so it would end up becoming the same function. Same idea if, let's say, I chose a parabola here. And this one here, if I took this point right here and I reflected it over, it lands on this point and then vice versa. So really I need something that is symmetrical, has a reflection symmetry here, to create something that would be the same when scaling it horizontally positively or negatively. So lots of options. Those are the 2 that first come to mind for me. That looks good. Onto our spiral review, problems 9 and 10. Here's a function, f of x equals -2x squared plus 4x minus 4. Does the function have a maximum or a minimum? So the first one that I think of here is that this is a function with x squared in it, meaning it is going to be a parabola, meaning it either is shaped like a U or an upside down U. But when I look at this problem specifically, I see that it has a negative sign in front of it, which means that we are flipping it or reflecting it and making it point down. So it doesn't look like this one, which means that it is going to have a maximum value. Next, it asks us to determine the coordinates of the vertex. There's a couple ways that we can do this. We could either find the zeros, meaning like where it crosses the x-axis, and find the halfway point in between those two, or I'm going to actually use one of the equations that I know to help me with this. It's called the axis of symmetry. And if you don't know this, or maybe don't remember it from a previous class, the axis of symmetry tells us where on the parabola, in this case it's a downward shaping parabola, what x value this is here. And so that really tells us what is the x value of the vertex. And the axis of symmetry, there's this equation that we use, and it is negative b over 2a, where b is this number right here, and a is this number right here. And so when I plug that equation in, I get negative 4, because that's b, over 2 times negative 2, because that's a, negative 4 over negative 4, which is now 1. And so I know that the x value of my vertex is 1. So when I finish this problem, it's going to be 1 comma something. Find the y value of the vertex. Well, I have this equation that if I plug in an x value, it will tell me the y value. And since I have an x value, I can just plug it in. So if I'm saying f of 1, I'm going to have negative 2 times 1 squared plus 4 times 1 minus 4. That becomes negative 2 times 1 squared. 1 squared is just 1. 4 times 1 is just 4. Negative 2 plus 4 minus 4. Now when I do this, negative 2 plus 4, I get positive 2. And then 2 minus 4 is negative 2. So f of 1 is equal to negative 2, which means my vertex is going to be at 1, negative 2. So again, I don't know if you know about the axis of symmetry, but it's a nice little equation to help us find the x value of the vertex. That'll go ahead and wrap up our Chapter 1, Lesson 10 practice. We got 1 or 2 more maybe lessons to kind of go through the practice for this chapter, and then we will be wrapping it up.